Welcome to the Industrial Talk Podcast with Scott MacKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, once again, welcome to Industrial Talk. Thank you very much for joining this platform that celebrates you, industry professionals. Thank you for what you do, and thank you for your continued support. We just believe in you solving all the problems of this world and making the world a better place. That's why we celebrate you. We have a great conversation. Gradyent is the company. That's Gradyent.ai. And we're going to be talking about digital twin and the STEAM network. How about that? The application for digital twin and how it's applied to STEAM. That's pretty doggone cool. Her name is Tania Schulze. Let's get cracking. Yeah. You do so much with digital twin. So much. I think we're just tip of the iceberg. We've got so much more that can be done. The only thing that I can give you in light of all this great stuff that's taking place, you just got to continuously educate. Find the answers. Find the individuals that can definitely help out. Educate, and then you collaborate. Collaborate with those individuals and say, hey, I want to know more. We're on this journey, blah, blah, blah. You get the picture. Educate, collaborate, and without a doubt, it is a time. It's a renaissance to innovate. So there are tools, strategies, techniques that exist today that will help you just deploy the innovation you need to be successful, because we want you to succeed. And I'm sorry for clearing my throat. I got a little cold happening there, but that's okay. No big deal. We'll soldier on. All right. A little bit of business. One, if you are not podcasting, if your business is not podcasting or making an effort to podcast, I'm just telling you right now, you're missing out. It is the time to do that. People want to hear what you have to say. It is important that you are out there telling your story, and then working with other companies to be able to tell their stories. What happens is the reality of, one, you're going to have a great relationship with those individuals that you work with. How can you complain against that? And then hopefully, the way I did it, use that relationship in a way that we come together mutually for business. If you're not podcasting, you need a podcast. Now, two, if you decide you need a podcast or you are podcasting, Industrial Talk, the platform, is here for you. It is a collection of industrial conversations. I don't have to go to Spotify. I don't have to go to these platforms to try to find that information. It's all there. It's all available. And because we want to educate, collaborate, and innovate, what better place to do it? Put your podcast, or if you're thinking about podcasting, I can help you. I'm an open book. We want you to succeed. Put it out on Industrial Talk. And then there's the final one. You're saying to yourself, Scott, I don't have the bandwidth. You're making a bad decision, but I'll let you go. But you have a story to tell. Just let me know. Get on Industrial Talk. Let's create the content. Let's create the information. Let's get it to your marketing people so that you can push it out, get the traction you need, get on a program, have the conversation. It can be webcasts, it could be podcasts, it could be, anything that generates media. You can give life to your blogs. If you're writing a blog, put a human face on it. How's that? Put a human face on it. And that means being able to tell your story and use that as a springboard to be able to tell your story. Bottom line, do podcasting. You need this for your business. All right. We're going to be talking about digital twin. And if you don't know, that's the digital side of your physical assets, your physical world, right? And you're able to do a lot of things in the digital realm that you can apply to your physical realm or your physical assets. Run some simulations, whatever it might be. Look at how your operations is performing. But you can do it right there. It's all good. Digital twin. I like this conversation because I'm so asset centric. Like, okay, here's a motor, here's a valve, here's my twin of what is physically out there, and this was sort of an aha to be able to digitally twin your steam, your thermal requirements for your operations, and what makes it so powerful is the fact that you have the documentation, what you need to be doing at the right, all of that information. And you know what? Based off the conversation with Tania, the reality is that this can be lifted up relatively quick, and you could be reaping the benefits today, tomorrow, in a couple of weeks, and seeing what's taking place in your organization. There. You gotta like this conversation. At least be able to strike up a conversation with Tania. So here she is. Tania, enjoy the conversation. Tania, welcome to Industrial Talk. How are you doing today? All the way from Berlin.
Hey, Scott. Thank you very much for inviting me. It's a pleasure. So I'm doing well. I'm calling in from Berlin, Germany, and I'm very happy to have the discussion with you today.
I'm all in. Listeners, we're going to be talking digital twin, but we're going to be talking how it's applied to steam. Make a note of that. I didn't say stream. I said stream, which doesn't make sense. Steam makes more sense. So that was just me. Steam is on the conversation. Tania, before we get going and dive into digital twin and how it's applied to steam, give us a little background on who you are for the listeners to understand why you're such a great professional.
Yes, for sure. I'm working in the industry for almost 10 years. So in the oil and gas field, in the engineering field, and in the energy sector. Started as a strategic consultant in IoT, Industry 4.0, always looking for companies to help them find new business areas and new markets to enter. So basically doing better business development with them. Also did a lot of startup consulting on what's a great business model and how they find actually clients that want to work with them and companies that are far more mature with them and offer their innovative services to them. And then I had several sales positions throughout the years, always related to something technical. So for 3 years, I also worked for a predictive maintenance startup here in Berlin, where we actually built a digital twin for gas turbines, pumps, and motors and compressors. So really in chemical sector and the refinery, everything that moved to predict when they fail and how to optimize the energy efficiency. So, and currently I work for a Gradyent, which is a Dutch company based in Rotterdam that builds digital twins for heating networks. And I'm responsible for the industry part of it, where we actually monitor steam networks.
There you go, man. You have mad skills. You've seen a lot of changes. I mean, if you've been in the business for 10 years in the IoT, the digital side of things, I mean, you've got to just be amazed at where you were at today, where you started and where you're at today.
Yes, of course. I mean, when I started, I worked with a company from Würzburg where they developed a software for smart glasses to actually do smart glasses in warehouses, which was one of the first applications then. I mean, almost, 8 years ago where it all started. So where it was very rough, and we wanted to explore, for example, how these smart glasses could be applied to the oil and gas sector.
Yeah.
Because we all want to have hands-free, so low-risk operation. But then you, of course, at that time had the problem but these glasses were not ATEX approved, so they had no explosion improvement, right? So that was the questions that was faced then, and I mean now they are also reality. I mean,
Yes.
still not widely used, but they are used in a very professional way. It's cool to see how these trends not only be trends, but they actually are applications in the field and working now.
See, it's interesting. I went to an event and there was an individual that had, or a company that was producing these smart glasses. This was just recent. So he allowed me to put them on and then be able to see the world through those glasses and see how the how they benefit or would benefit industry is phenomenal. We're still, I just get a sense, Tanya, that we're still on the sort of that tip. We still have so much to achieve. It's exciting. It's an exciting time.
Yeah, of course. And there's so much that is still, I don't know, in progress, I would say. There's cool stuff that is already implemented when it comes to
Yeah.
Industry 4.0, but we are still on a very low maturity level. If you
Yes.
ask me, there's so much more far ahead of us. And especially in the field where I work with, where you have existing plants in the brownfield sector. So
Yeah.
existing plants, then the question is always how we can actually improve them, and is it even applicable, these new trends, and if they are, how can we actually implement them? And that, I think, is the major challenge for all of that.
Yeah, and pulling it all together that makes it relevant, that makes it tactical, it makes it beneficial where I am achieving the optimization that I desire, the safety that I want to achieve. All of that stuff has to work together. And I always talk about having that technology individual, that Sherpa that can help you along with that journey. If I was a in the oil and gas, I'm doing oil and gas stuff. Do I have the bandwidth to do some, all this other fancy stuff? I don't. I need trusted professionals to be able to take me on that journey. They got to do it. They've got to do it. All right, I
Yes,
digress.
yes, and they're also doing it, but
Yeah.
sometimes if you work with them, then you have very practical issues sometimes. For example, once I talked to a client where we wanted to implement more sensors, for example, vibration sensors or another pressure or temperature sensor. And then the question was, yeah, but where do we get the electricity for the sensor actually from? So
Yeah.
because we have no electricity in that part of the site. So the only
Yes.
thing that we have is the street lantern. So
That's
these
exactly
are
correct.
practical things that you have to face with these things. This is also the problem that we face with Industry 4.0 application in general when we talk about maturity level. It's not only the maturity level of the technology, it's sometimes just the feasibility on site that hinders
But
them.
it's gonna happen. It's happening now, without a doubt. Now let's venture into our conversation about digital twin and the STEAM networks. For the listener out there who doesn't really truly understand what digital twin means and why it's beneficial, can you explain us what digital twin is all about?
Yes, for sure. So there's several definitions. I mean, the basic definition, it's basically the digital asset of your physical asset. So it's basically a digital twin copy of your physical asset, and that can have different functions. So it could be very simple that you, for example, do a product twin where you just try to digitalize the product and see how it would work, or where you want to design it or visualize it. But when we talk about digital twins for monitoring in industrial sites and optimizing for industrial sites, we're talking about, okay, a monitoring solution that can find optimization potentials, that can predict failures, these kinds of stuff. So digital twins have different layers based on the application you're looking into. They can differ. So the word digital twin is quite fuzzy, so to say. It's more
It's broad.
what kind of application and use case do you have, And for these networks, definitely for sure, it's monitoring, gaining deeper insights about the network by calculating, for example, more sensor data, then finding the optimization potentials based on these insights, and also maybe predict something in the future. Could be either maintenance or just do forecasting for, I don't know, for example, steam demand in this case.
Yeah, so you're saying that I have a digital representation of my physical world, and then in that digital representation, I can run scenarios. I can the date. It's all driven by data. You need to have the ability to be able for your digital uh, twin to be able to pull in. Are we pulling in real data?
Yeah,
Yeah,
exactly. In this case, we are pulling in real data.
yeah, and I'm able, and I guess the benefits for me is, let's say, pre-digital twin, I would have to see if I change a pump out over here, did it work? I'd have to see it, physically experience it, design. Here I can run these scenarios in the digital world and see, yeah, that's the right pump. I put it in there. These are the stats. It works well. I can then go out to the physical and feel comfortable that I did it right, which is very efficient.
Yes, exactly. It's about the validation of the
Yeah.
optimization potentials that you see. So
Yeah.
basically, you're also harmonizing different data sources,
Yes.
and maybe also can gain better insights about that to do actually optimizations. For example, if we look at steam, where the steam production is a specific case for that, where you want to optimize the source dispatch, so the boiler dispatch. So you take into account the boiler efficiencies, then the fuel mix we run on, then the load of the boilers in itself. And sometimes that's not so obvious if you just look at a DCS system where it just gives you the control data of the boilers. So it's not easy for the operators to actually find these optimization potentials. So they have to do or run different calculations to do that, and they don't have the time for that. And this is why such a solution then comes into place that takes this job.
I have to say, and that's brilliant. You're absolutely right. And this is really the first time on Industrial Talk we're going to have a conversation around that the thermal side of these processes. It's always from a digital twin perspective. It's always been here's an asset. It's a motor. It has vibration, devices on it. It has also thermal devices on it. It has devices on it, and I'm collecting all the data and all of that good stuff. This is the first time I'm having a conversation, which is if I'm looking at a process itself, a manufacturing process, that whole energy side is so important, and optimizing that just makes complete sense. So take us through a scenario where you would begin to digitally twin the steam process.
Yeah, sure. So what we do at Gradient is we actually have a hybrid modeling approach, which means we use physics-based models, which in this case are thermodynamics and thermohydraulics. So we take quite a lot of domain knowledge from the engineering aspect, and then we are combining them with machine learning and AI algorithms. So therefore, you actually don't need to have so much data for the training because you already have the validation from the physics, and you also can better validate your outputs of it. So this is why you can actually then estimate and also calculate and analyze the whole dynamical behavior within the whole network. So what we take into account is everything from the production of the steam and every pipeline, the whole distribution. So we model every pipeline in the length, diameters based on the P&ID data, the geospatial data, and then also the end users. Because we use this kind of modeling, this hybrid modeling, we also are able to calculate more sensor data. And therefore, you also can have more insights, for example, in unmeasured users. And what also comes into account is the weather data. For example, rain has a huge impact on
Yes.
how the network behaves. what the problem is for most of the companies, if you look, because you have like these large steam networks in refineries and in chemical plants, on pulp and paper, or sometimes also in food and beverage, they have a problem with closing the steam balance because these networks normally don't have too much sensor data on it because it's not the primary process within the plant. So the primary process within a refinery is actually creating more products out of crude oil. So these steam networks were overlooked over the years. So they don't have the best data situation in that. And this is a little bit the issue that they're facing the problem of closing the steam balance and finding the right optimization potentials for it.
Oh, that is so cool. And I never thought about this, that unlike sort of that physical side where you have a pump and a motor and the impact of that from an environmental perspective, like it's hot over here, it's cold over here, it's whatever the impact of that environment can affect the asset, the physical asset. But to your point, the physics of the thermal side makes sense. You're absolutely spot on. But here you go. Here's a situation. I say, yeah, Gradient's great. I like what they say. How do you approach? I mean, it's a refinery. It's all tubes and it's a refinery. How do you approach and incrementally begin to affect the proper changes that are necessary, the optimization? Where do you go? How do you say this is where we start?
And that's actually always a question depending on the refinery or the chemical plant, because
Yes.
we can do two things, right? So since we are able to mimic the whole dynamical behavior of the network and what's going on, how the steam is routed through, right? So then it's basically more on what also their initiative is. Is it currently more looking into optimization potentials where they can reduce costs? Or is it more about a decarbonization where you actually want to increase your energy efficiency? Most of the time, it's both of them because they go hand in hand. But it could be also that you want to look for transformation processes. For example, you also can simulate future scenarios. They can put in an e-boiler or test new operating parameters. We had a client where we actually simulated the whole network, and one user was going out of the network and they wanted to change the piping. So we could simulate that and tell them, okay, your current planning is actually leading to more condensate. And this is the questions that you actually want to answer. How can I safely and risk-free run my operation on the steam network and guarantee the same steam quality in it without condensation, water hammering, all these kind of issues that you can face, or even venting out steam because you are not able to track it to another route or to another user within the network.
I suspect it's just because your Gradient and you and other individuals within the organization focus in on those process manufacturing. There's a safety component. There is a major safety component where you don't want to just start willy-nilly start turning valves and and it's just like I see the benefits of being able to create that twin effectively and then be able to, from a safety perspective, then optimize accordingly. Like, does Gradient provide the devices as well, or do you work in conjunction with other organizations that say, yeah, we have a device that will be collecting or doing it? It's all physics, whatever. Do you guys work with organizations, or does Gradient also provide some devices too as well?
Currently we actually were able to build our twin without additional sensoring. So
Right.
we really take, so we build our own models, and they're quite accurate with nice optimizer models on top of it. So we really take the data out of the DCS system. We take
Yes.
into account all the P&ID data and also the geospatial data, the weather data. Sometimes we also go over the plan to really see if the pipeline is going up or down. So because we also model this and we also have a 3D visualization of it, so we really can see also between the layers of the levels of the pressure, if it's a high pressure, mid pressure, or low pressure line. We also can distract that in our 3D visualization, that you actually can see what is going on there. That is a nice benefit. But what really comes then into place is the plots for all the pressures and temperatures, return temperature, for example, forward temperature. We really get nice insights into each of these category, where we also recommend then the set points based on the analysis that we are running. So we analyzing the data every minute, then giving set point recommendations for every 15 minutes, because you don't need to constantly change. So it doesn't not make sense. Also, temperature is quite slow in behavior compared, for example, to vibration.
Brilliant. Absolutely brilliant. I love that. Do you have some situations where the PNIDs, you're saying, okay, here's the two, this is the way it's supposed to, and then you go out in the field and it's not there, or it's one diameter versus another diameter. There's a disconnect between what exists within the office versus what exists in the field. Do you have to normalize that? You have to.
Of course, sometimes you face that. I mean, there were times, I think I talked to a client, he said in the 80s, the documentation were not so good, but we did a lot of changes there. So it's definitely something you will find in every industrial plant, I guess. So it's not always easy to get the right data, that's for sure. And I think that is also one of the bigger issues in general, if you look for these Industry 4.0 applications, AI applications. The first thing that you need to do is actually have a data strategy, making sure you have the right data quality, also harmonizing the data in itself. So for sure, that is also a task that we then normally get. So we actually do the whole modeling of the pipeline. We do the data cleaning, we do the data validation, we take into account also the limitation and constraints on site. Sometimes you have constraints like, I don't know, the pressure level always needs to be constant or something like that. So it's not always, it's not an easy task, definitely not, but it's also a doable task, and we have quite a lot of experience there. We started in district heating with building digital twins for large cities. For example, in Helsinki, we are monitoring the whole district heating network there. And we are doing this now for industrial sites, and it does come with new challenges for sure, but it's doable.
I would suspect, and when we start talking about the data side and cleaning up that data and normalizing the data and making sure that it's accurate, that's foundational to whatever your efforts are with the digital activity. But do you find, unlike the physical side where I got a motor, and in that motor, the question always happens around, how far do I go back in the data? How do I create that knowledge base, and how far back do I go? In the case of your approach, because it's so driven by physics and science and all of that, do you have to really go back that far to make sure you're just trying to validate the data as is today and then be able to then go forward, right?
Yeah, so I mean, the more data, it's always better.
Yeah,
That's for sure.
yeah.
But a minimum of a year or two, two would be actually better, also to get maybe some seasonality things right, or if you heavy chemical side that produces different chemicals also has a huge impact, right? So we say normally 1 to 2 years of data would be
Very good.
sufficient enough to train the model. And then we do actually, for the whole process, when we do such a digital twin, it normally takes at least 6 months to build such a model, because we first get the data, which is normally takes also quite a while.
Right.
Then we are validating it, then it gets cleaned, and then we have different validation workshops through this process of building the model in itself. So where we actually go back to the client, ask the engineers some questions, weird conditions that we found, or for example, conditions that might be critical for the operation, A, to showcase, hey, we found here something, or B, we have found something that we are not sure why is it happening. So for example, could be pipeline resistances that you have there, or I don't know, something like that. Or we also could tell a client, for example, where we modeled the whole network, that the flow meter was actually drifting and was wrong calibrated, and they used it actually for billing. And that is an issue. If you have
That
like
is an issue.
huge issue if you're just 5% off, you're not only 5% off in your billing, but also in your emission tracking, right?
Yeah.
So you have to report your emissions. So therefore, it's not good to actually take like a flow meter that it's completely wrong. And we could validate the real data with our twin. And this is something that we do within the process of setting up these models. And then if we feel comfortable, very comfortable with our model, then we actually set it live at the client. So the digital twin actually gets the live data constantly and can optimize it constantly, so they can use it for the monitoring and the optimization.
Yeah. See, I'm all giddy. I think that is just I see so much benefit that comes from as a result of being able to track that and do it and proactively optimize your facility. It makes complete sense. What are some of the roadblocks? Why would I like? I hear what you're saying, Tanya. It's fantastic, but I don't. What are some of the pushbacks?
I think some of the pushbacks are for sure never change a running system.
Yeah,
It is one
see,
pushback.
yeah, that's exactly. See, they don't want to touch that. It's just, yeah,
So gaining that trust, especially with the plant operators or even I don't know,
yeah,
process engineers on site, is always I think the first constraint. Then the second question is, why are you so much better than the existing solutions?
yeah,
Which is also, I think, a very valid question, right? So it's all about gaining trust in the end. And there's not a lot of really live optimizations there. So you have quite a lot of offline models in this space where you just calibrate it and then it's, I don't know, you see it for the moment, but you don't have this constant calibration. So this is one of the issues on the market, that there's not a lot of options where you really do the live optimization, or they just focus on the primary processes and not so much on the steam network in itself. As I said, focus in every chemical refinery is first optimize the primary processes and then the secondary, and steam is the secondary. So this is one of the pushbacks, and I guess really like believing in the modeling that we do. So sometimes we actually do some modeling for them and really trying to gain the trust over time, so we could showcase our clients cool impacts that they haven't seen so far. For example, the impact of rain on the pipeline
yeah,
that they haven't seen before. And I think that is the problem. So most of the time, these networks are actually monitored just by the DCS system, and that has a limited value in that sense, right? Because you don't have quite a lot of sensoring there, and you also don't use your DCS system to actually optimize something. You use it to control, and that is one of the issues. So, and if you're not able to do more, then the question is, okay, what's the next step? Do I do the calculations by myself? Do I try to model it by myself, or do I use a full-term service like Gradyent, where I get the model, I get the constant updates, and all the headache of this whole modeling thing is actually with us?
Yeah, I think the latter is probably the ideal scenario. But I hear what you're saying. I think it's great. I think that there's a lot of efficiencies to be gained if I was able to see my process from a digital perspective, optimize that process to ensure that the quality of my product, the safety of the asset, all of the important components of my business are optimized. I just think it makes sense. I think it's a fabulous approach. I really enjoyed it. Tania, how do people get a hold of you if they're saying, I want to know more about this? I want to kick the tires of Gradyent. I want to have a conversation with Tania. What's the best way to get a hold of you?
Yeah, of course. You can find me on LinkedIn, or just get to the webpage Gradyent.ai and just let us know that you want to talk to us. So there's different methods to catch us there.
And Gradyent is Gradyent. So that's how you spell Gradyent.ai. So if you go out to that website, you'll be able to find all the information about that. You were fantastic.
Thank you.
Well done. Well done. I enjoyed that conversation. Yeah, it was pretty good. I enjoyed that conversation immensely. I wish I was younger, just because all of this great stuff is happening, and it's just what you said before. It's just that we're just at the beginning of it. So anyway, thank you very much, Tania, for being on Industrial Talk.
Thanks so much.
All right, listeners, we're going to wrap it up on the other side. We're going to have all the contact information for Tania. You need to reach out to her. You need to reach out to Gradyent, the company. Find out more. This is important stuff for your organization. So you need Sherpas like Tania to be able to help you along with that journey. All right, we're going to be right back.
You're listening to the Industrial Talk Podcast Network.
What'd I tell you? How about that for a conversation? Learned a lot. That's a paper and pencil conversation. I enjoyed that tremendously. You need to reach out to Tania Schulze. Her contact information is out on Industrial Talk. The company is Gradyent. That's Gradyent.ai. And again, we're talking about education. Make it happen. We're talking about collaboration. There she is. We're talking about innovation. They're doing that, right? Steam. How about them apples? All right. Again, to reiterate what I mentioned in the beginning, you need to be podcasting. You need to do that. You need to be able to bring attention to your company. We want you to succeed. This is something else in your toolbox to help bring revenue to your organization. I'm here as a resource to help you succeed. What can I say? Be bold, be brave, dare greatly. Hang out with Tania. Change the world. We're going to have another great conversation shortly, so stay tuned.